going to be launching what's called a high-pressure paper rocket. This rocket is extremely dangerous. Just like a sheet of paper, you can get a paper cut, right? Well, with this, you could get hurt just because it has a pointed part, and that can hurt. This rocket has some play in it, so it has weight to it. We're going to pass the rocket around. I don't want you guys moving it around, just hold it in front of you. I don't want you turning it. Okay, take a look at it. I'll take the other one. Look at it real careful. Be careful because it does have sharp points. Notice it has two different sizes. You guys are going to be able to get this 3/4 inch PVC pipe. And in order to make the body, you're going to have to roll paper onto the PVC, because that's what I had to do. When I rolled the paper onto the PVC, I had to tape it in place so that it stayed as a roll. You guys can't see anything, and I've made sure that there's a cap on top of the paper, because when I push air through this pipe, it's supposed to go off. Okay? In order to get the air to go through there, I've got a launcher, and just like I forget who explained, I believe you did, I got a compressor, and I'm going to load that launcher with a lot of air pressure. And then I'm going to release the pressure all at one time by rotating a valve. And this rocket, I hope, to go really high. Now, you guys just looked up there. Did you see how high it went? I didn't. So the only way I'm going to figure out how high it went is I have to use some type of method for collecting data. That's what we engineers do. We collect data. I assume that all of you know what an inch is. Now, 1 inch is about that much. But if you all just take your thumb, raise it up, and you see where your knuckle is right there, and move your finger right up to your thumb, that's just a little over an inch right there. You guys go back, you guys can prove that for me. From your thumb, top down to the knuckle is just over an inch. You guys can go back and prove that, alright? The reason why I need to know all this dimension is so you know how many inches make up a foot. 12 inches. Good. And let me see here. So, if 12 inches equals a foot, right? How many is 10 feet? In inches, 120. And what'd you do? Simple math. 10 times 12 inches equals? And how many feet did I ask for? 10. Great. Well, you look over there. From this first orange stake to the next stake is 100 feet. Did you write that down? It's 100 feet to the middle orange stake. And if you go from this orange stake all the way to the very last stake over there, that's 150 feet. I think that I can get my rocket to go greater than 100 feet. But if I'm looking like this, can I measure 100 feet just looking at it like that? So I've got to figure out a method how to do that. And I'm going to do some drawing in the dirt here. Alright, let me think now. Okay, if this is where the launch pad is, you see that orange thing? That's where the launch pad is, right? If I draw a line way over here, there's that first orange cone. So launch pad, orange cone. How far is that orange? 100 feet. So I'll put down 100. That's 100 feet to that. Do you see that? Okay. You guys are going to have some imagination. Okay, you have some imagination. That launch pad, the rocket's going up, isn't it? Rocket goes straight up, right? There's 100 feet way over here. Would you agree?
Yes.
Do you guys work on triangles? You know what a triangle is?
Yes.
Really? Well, watch this. Did I just create a triangle right here?
Yes.
You see that? To here, to there. Is that 3 legs?
Yes.
Okay. You see this one going straight up?
Mm-hmm.
They call that 90 degrees because it's going straight up. Now you see this right there? See that part? Well, that's an angle. Do you know that?
Yes.
Really? You guys know that?
Yes.
You're in the 4th grade. You guys know about an angle?
Yes.
Really?
Yes.
Okay, seriously?
Yes.
Okay. Well, then if you guys already knew that secret, then, oh man. Okay, listen. See over here? How far away is that?
100 feet.
If I launch this rocket and it goes 100 feet, okay, did you just see that? The rocket's going where?
90 degrees.
90 degrees, straight up. Okay. Do you see the 100 feet right here? And there's 100 feet that way? Well, this angle right here, if you're using this tool, would equal 45 degrees. Now, 45 degrees. I can actually measure by knowing the distance here. Now, I'm trying to make this simple because you guys aren't kindergartners, right?
No.
Oh, man, that's good. I was getting worried. So this is what we're going to do. We're actually going to try to measure how high the rocket goes. To do that, I got a special tool. Now, look, I'm going to trigger this. You see how that moves? So, if I go like this, it goes straight up. Now watch. You see how that's moving? I'm actually following the rocket. And if I stop there, 40 degrees. Now, if it's 45 degrees, it went 100 feet. If it went less than 45 degrees, what do you think? More than 100 feet or less? If it went more than 45 degrees, more than 100 or less? All right, let me try this again. Higher than 45 degrees? How? More than 100 or less?
More than 100.
Right. Less than 45 degrees? Good. I'm going to show you guys how to make the nose cone. I'm going to show you how to make the body and the different types of fins. What's really... Okay. This is going up, right? Why does it want to come back down to Earth?
Because of gravity.
Good. And say this for me. Gravity is constant.
Gravity is constant.
One more time. Gravity is constant. What goes up?
Comes down.
Unless it gets past Earth's atmosphere and gets into space. Now, once it does that, it's in space. Gravity effect after it leaves Earth's atmosphere, it's not, there's no effect. So are you looking at me?
Sorry.
So, what we got to do is this. When this goes up, there's no wind. You see any wind?
No.
If the wind blows this and it starts coming near you, I'm going to tell you guys you need to move. You guys hear any air? No.
That's because we have compressed air in India.
That's right. And this right here, okay, move. That's where my air is going to come in. It's coming from the compressor. I have a gauge to tell you guys how many PSI. I want you guys to write down the PSI when I tell you what it is. The first, I'm going to do at 50 PSI. The second time, I'm going to do it at 80 PSI. We'll try both rockets at 50 PSI and see how high they go. Well, you want to try 100?
How much does it go to?
Okay, did you want to try 100?
Yes.
Okay. Did I tell you?
It goes to 100.
When I put this on here, we're going to have a countdown. Your countdown is going to go 5, 4,
3, 2, 1.
and then I'm going to launch. Now, if you guys aren't careful, you're not going to see the rocket. It's going to go that fast.
Really? I'm going to run for that.
Okay? Okay. You see the smiley face?
Yeah.
That's what I want you guys to hold the paper. Smiley face style. There's a dot. You may not see that dot, but I put the dot so that it's the center, pointing me where the center is at the top of the smiley face. Now, I'm going to find that dot. You don't see me because I have to look at my dot, and I'm not creasing the paper, but I'm trying to find, oh, this is center, and a little crease, only at the top. Only at the top. You see that? Whew. Here comes the part. This is the breathing one. Where the crease is where the point of my nose cone is going to be. Now, I take this side and I fold it down right to the point. And then I fold this side over and I grab the tube. Are you watching?
Yes.
And then, this is tough to explain. I got my thumb inside, I've got my hand outside, and I'm going against each other, but I'm dragging the both hands together. But I'm also pushing down and pushing up, and when I get done, no, that's tough, because the nose cone, depending on what kind of body it's going to connect to, can't be so big that, look, that's a hat. That does not look like a nose cone. That looks like a hat. So the only way to get this hat so that it becomes a nose cone is go back, push and pull, turn and turn. You guys can't see this because it's all secret. If I show you guys would go, that was cool. And now I go check it, and that's the nose cone. All right. For us to do this, what I'll need to do is we're going to have to cut out some nose cones. And just cut out yours, and then you can finish it later. All right, so you can start cutting yours. Cutting out. You need to start cutting out. And start cutting out. Hey, here. Yours. Here's yours. All right. How you guys doing? Oh, man. Okay. You got it cut out? Oh, you know, that was pretty smart. You didn't even have to find the dot. You just went ahead and then gave it a little crease. Is that what you did?
Oh,
Really good observation.
it's really tiny, but
You don't have to wait for me. Make your nose cones. Practice. Remember, you have to go smiley face down, crease at the top. Right. Smiley face down. Like this. Crease. Down. How they go? Over top. Right. Sit. Smiley face down. Like this. Crease. Down. Gotta go. Over top. Right. See. Well, what about that part? Remember? Smiley face down. Okay, listen. You said you had a problem with your point closing. If your eyes, let me see your eyes, please. You see how my paper's already been wrapped up? I see how to finish with your fins. But for those of you who have already cut your fins out, you're going to have to start preparing your fins. See the lines on there?
Yes.
Those are now fold lines. Don't look over here. Look at me. Those are now fold lines. Well, your first fold. Let's all try to practice together. I'm not sure. Put them down. Put them down. But I want you to. You're practicing with me. Watch carefully. There's a center line, and I'm going to make sure that I can see the line from the outside, and I've got to match these up as best as I can and crease. Ooh, I'm a little off. I can just see that. But you see how they matched up on both sides? Then, what do you think I should do next?
Oh, get the body?
Well, see, I gotta put this on here. So if this is the body, I gotta put it on there. Yeah, but how am I gonna use tape to hold that on?
You get a glue stick. Well, first you have to hold the.
Oh, good. Oh, make some flaps. Okay, this. May I borrow your table? All right. Now, because it's folded flat, I've got to raise one of the flaps toward me on the line as best as I can. Then I turn it over and I raise the other one as best as I can. Oh gosh, this is not easy because I got to get it right on the line.
I'm making a paper thing with regular paper.
And look at this. So I open the flaps up.
Now you put the new one there and put it on.
Or I can use tape and look at the fin.
Never hot, so I really do.
Oh, but I've got to make sure I close this off in the back there. So you might want to put some tape. But these are practice right now. So there's my first fin. And I make sure by creasing this really good
that it can stand.
It should sit on your desk just like that.
Yeah.
And if I make all my fins differently, then I make an unbalanced rocket. If I make all my fins differently, I make an unbalanced rocket. So does that mean all of them have to be folded properly as best as I can? Finish cutting out your fins, start folding. Only for each one. Be very careful, don't cut yourself either now. Question was, are we actually making a rocket? Oh yeah, all those materials, I hope you're not throwing anything away. These are all the parts you need. You need a nose cone, you need fins, and what else do we need?
Body.
The body.
How I'm folding is that I'm folding the whole top of it first, and then I'm folding these right here.
Okay. I'm gonna watch you, okay?
You have to be able to read start here. There you go. Let me see yours. Yeah, good.
Oh.
Make sure you try that. Oh, thank you. I can go. Oh, yeah. Oh. You can tap
Yeah, we can put another practice. So you have do I need to make more?
Oh!